So here we have a combinational circuit and we're trying to find V0, the voltage drop across R2 and R3. Now this is a combinational circuit because R2 and R3 are in parallel, but then there is R1 that is in series with R2 and 3. So how do we actually approach this problem? Well, if we combine R2 and R3, then we're going to just get a regular series circuit, and then we can easily find what the voltage drop across that new resistor is. So we can say R2 plus 3 is equal to 1 over 20 plus 1 over 30 to the negative first power. And this is going to equal to 12 ohms. So these two resistors together is going to be 12 ohms. So let's actually redraw the circuit. And now R1 and R2 plus 3 are just in series. So all we need to do is use Ohm's law to find the rest of the problem. We know that voltage is equal to current times resistance, but we don't know what the current is. Well, we know that current is going to equal to voltage over resistance. And we know what the voltage is, and the resistance is very simple to find. It's just going to be R1 plus R2 plus 3. So it's just going to be 12, or 18 in this case, plus 12 ohms, which is just going to equal to 30 ohms in total. Then we can say that the current, we can use this equation. We can say current is going to equal to the 5 volts that we're given as the source over 30 ohms, which is going to, well, let's not actually simplify it. Let's just leave it as 5 over 30. And then we can just come back in here and plug it into this equation to find out the voltage drop across each resistor. So we can say V1, for example, let's say the voltage drop across R1 is going to equal to 5 over 30 times 18 ohms, because that's the current times the resistance. So that's going to equal to 3 volts. And then we know that 3 volts is how much voltage is dropped across R1. And we know the voltage source is 5. So we know the amount of voltage going through R2 plus 3 is just 5 minus 3, which is equal to 2 volts.